Hello, I'm going to go ahead and talk to you today about Boolean operators, which is kind of a big, weird word. But it's basically, these are little operators, words that you can use to define the relationships between your search terms when you're doing a search. You can use these on the internet, and you can also use these when you're searching the article databases. For instance, if you're looking for academic articles. Basically what happens is when you do a search, you define a term and you enter that into like a search box. Like if you look at Google, you normally have like one big search box in the middle of the screen. It looks something like that. And you type your term in there, and what it does is it looks for that term inside the documents in the collection. Now, Google does something a little bit more complicated to determine relevance, but at the basic principle of it, that's what's going on. And a lot of databases, essentially what they do is just look for that term in the documents, and if they appear, they bring those documents forward. The Boolean operators allow you to define the relationship between two terms in order to expand or limit or kind of customize your search results, and they can be really useful and powerful tools. In Google, you see one big screen like this. In a lot of article databases, you'll see one big search box like this also, as something called the basic search. But if you look around, you can often find an advanced search, which will include additional boxes that you can use with little pull down boxes that you can use to define the relationship between the terms. So I can define how these two terms relate to each other and so forth, and how each term relates to my search. Even if I don't have these extra boxes, I can still define that by having term one, and then like an operator like and then term two. It's just not as easy to do it this way, and the syntax of it can get a little bit complicated. Okay, so in order to explain a few of these kind of common, very useful Boolean operators, I'm going to define a small collection. So I'm going to make the world's most useless collection of documents. And my collection of documents is going to be a database with 4 documents in it. And these are going to be represented by these 4 boxes. And each one has only the terms I write in here. So this one says, I like cats. This one says, dogs are cool. This one says, dogs have fur, and so do cats. And this one says, I like birds. And that's it. Each of these documents, that's all they say. Like, there's nothing else in here. There's no title. There's nothing. This is just the entire document. Same thing for all of these, okay? And what I'm going to do is I'm going to do some searching. Now, if I just define one term, it's just going to find the documents that have the term. So if I do cats, I'm going to get I like cats. Not this one that says dogs are cool. This one that says dogs have fur and so do cats. Yeah, I'm going to get that one because it has cats in it. And not I like birds. Okay, so how do I define the relationship between my terms? Let's say I got too many results. And it may seem counterintuitive that you might get too many results, but it's true. Like, what if you get like thousands of results, but you don't know what the best ones are, and you really want the top results for you? So what you want to do is kind of narrow it down so that you get exactly what you're looking for. Like if I do a search for cats and I get all of these results, but I'm really interested in documents that talk about some kind of comparison between cats and dogs, then I probably want to add dogs to that search. Now, I want to tell you an important concept for all of these Boolean operators right now, and that is that the Boolean operators apply to each individual document, not to the entire collection. So if I'm going to apply a Boolean operator to my search, it's going to use that for each of these. Let's look at an example of that. I'm going to use the word and this is going to be my first one that I explain. And means that both of the terms that I include, the one before and after the word and, have to appear in the document in order to find that document. Now, when I said about applying it to the document, it's very important. when I apply it to the document, it's a limiting factor. That's the way they work. Some people think about it and their heads get kind of like a little bit twisted on the concept, and they think that it applies to the whole collection. If it applied to the whole collection, I would get every document with and, or with cat, and every document with dog, right? But that's not how it works, okay? So keep in mind that it applies to the document. That and is limiting, and it means that both of those terms have to exist in the same document at the same time. So if I do a search for cats and dogs, in order for a document to be relevant in that search, it has to have both of those terms at the same time. Okay, so if I look at my collection here, I have I like cats. Think about it for a minute. Do you think that it retrieves this document? The answer is no. Okay, it does not get this one. The logic that it goes through is it says, is the word cats present? Oh, yes, it is. Okay, so then it says, okay, fine. I don't know if I want that. Is the word dogs also present? And then it says it is not, and therefore the document does not contain cats and dogs, and so it rejects it. Goes down here, same thing. Dogs are cool. Well, it doesn't have the word cats at all, so it doesn't even bother looking for dogs. This one, however, it does get. It finds the word cats in the document. Okay, cats. I'm looking for cats and dogs. Here's the word cats. Okay, good. So far, so good. But does it also have the word dogs? Yes, it indeed does. And therefore, it retrieves this document. And then we have I like birds. No. Okay, so I have a little thing for you to look at that demonstrates how this works. Use 2 sheets of paper so that we can see it. That doesn't help. The back of this is making it difficult to see. All right, let's see. There we go. Okay, so here it is. And so if you can see, this is a Venn diagram that shows you which parts of the collection are colored, are retrieved in this search. You can see that it has 2 sides. It has the cat side and the dog side, and it's only the documents that have both of those terms that are retrieved. A very small portion of the universe of cats and dogs. Okay, cool. And then over here, there's some different ways that you might see them written in a search engine. All right, cool. So that's and. So now, let's say you have the opposite problem. You don't get enough results and you want to expand your search. Well, that's possible too. And there's a solution for that as well, which is OR. OR means I want any document with cats in it, with term A in it, or any document with term B in it. Okay, so that expands it and means that I want more documents. Okay, so like let's say I didn't find very much, but I'm like, you know what? I'm not really just interested in cats. I did a search for cats and I didn't find as much as I wanted to, but I'm really interested in just pets in general, and specifically the common ones. So I want to do cats or dogs. So I do a search for cats or dogs. So it looks over here, it finds the word cats, and it says, great, that's all I need to know. I don't care if it has dogs in it, it has cats in it. I want it. It goes down here, it says, does it have cats in it? No, but that's okay. Maybe I still want this document. Does it have dogs in it? And it does indeed, so it retrieves this document. Yes. This one here, it's all over, right? It finds cats. It doesn't even bother looking for dogs. It just takes it. And then I like birds. No, it does not take that one. Okay, so what does OR look like? OR is, so if we have the universe of cats and the universe of dogs, then OR is everything, all of it, right? Every document that has cats or dogs in it shows up. Okay, so that's what it looks like in a Venn diagram. Okay, then there's another really useful tool that I will show you, which is NOT. Now, NOT means there's a term that I don't want. How is this useful? Well, this is very useful for like narrowing down results, like if you keep getting results that you don't want. So I'm going to confess something to you right now. You don't know this about me, but I'm a huge fan of pirates. You know, like 18th century pirates, like, you know, the parrot on the shoulder and the blunderbuss pistols and raiding other ships. I love reading about pirates. The history of pirates fascinates me. I spend all of my free time reading about pirates. When I'm not teaching, I am basically just researching pirates. But I have a problem. My problem is that when I'm doing my searching, I often find articles about baseball. I do not like baseball. They bother me. They distract me from my pirate research. Why do I find these documents? Because there's a team called the Pittsburgh Pirates. And so in order to ease my frustration and have a more peaceful existence, I found it useful to limit my searches with a not phrase. Now, I needed to figure out, first of all, what term to eliminate. Do I eliminate the term baseball? Well, you might think so, but it doesn't really work that well because not every article about baseball really mentions the word baseball. What I found more useful was to limit the word Pittsburgh, because they always mention Pittsburgh when they talk about the Pittsburgh Pirates. Now, there may be a few pirate-related stories that I'm missing about Pittsburgh, and I have to do other searches in order to find them. But for the most part, it keeps me free of the Pittsburgh Pirates. Okay, so how would this look on our database? So we have cats, dogs. Let's say I want articles about cats, but I can't stand dogs. I don't want to hear anything about dogs. So what do? Well, I do a search that goes cats, not dogs. So then when we look at our database, we look at this one, it says, I like cats. Do we get that one? Well, yes, we do. It has cats in it. But the way it figures this out is it says, does it have cats in it? Yes. But wait, we're not satisfied with that yet. We want to make sure that it doesn't have any of those offensive dogs in it. So does it also have dogs? No, it does not. So yes, we do retrieve this document. Okay, how about this one? Dogs are cool. Rejects it. It says, does it have cats in it? No, it rejects it at that point. It doesn't even bother looking for dogs. Then we look at this one. Dogs are cool, and so, dogs have fur, and so do cats. So does it have cats in it? It says, yes, it does. But wait, I need to double check and make sure it doesn't have any dogs. It does indeed have a dog. We know that the person who made the search is a dog hater, doesn't want dogs. They said not dogs. I'm not going to give them this article, so it does not show up. And then I like birds. It does not show up. Okay, all right. So how does that look on a Venn diagram? That one looks like, here, my backing material here. That one looks like this. So you can see that the shaded area is cats, so the two circles are cats and dogs. The shaded area is what's retrieved. There's a middle area that has cats in it, but it also has dogs, and so therefore those do not show up. Okay, and that's the three main Boolean operators that are really useful. I guess there's one more kind of like little trick I might show you, which is sometimes you want to look for a phrase. And in most of these, you can kind of do this sort of down and dirty trick. Down and dirty, well, I guess it's not really down and dirty, but this quick and dirty, that's the word I was looking for, which is to put quotes around it. If you put double quotes around an entire phrase, then it will search for that phrase exactly. No, it has to be those exact words in that exact order in order for it to work. So if there's anything in between those words, it won't work. But if you put an exact phrase in there, then it will find all the documents that have that exact phrase. So like I could write, I like, in quotes. Okay, so I like. So I'm going to find any document that has the phrase I like in it. So if we look over here, this one says I like cats. Does it get that document? Think about it for a minute. Yes, right? I like, in exactly that order. Now, if it said, I will like, it would not get it, but it doesn't say that. It says, I like, so therefore it gets it. Dogs are cool? No, rejects it. Dogs have fur, and so do cats, rejects it. And I like birds. Finally, we get to retrieve that document with this phrase. And this phrase you can use in combination with any of the other ones. And if we go back to look at what I was saying, a typical advanced search looks like on a search engine, where you have like your multiple windows or your multiple search boxes, right? I can say term 1 and term 2, not term 3, right? And I can make different combinations of this. And I can do some really tricky things in order to customize my search. That's it.